Good morning, everybody. I always say that, but of course for you guys it might be afternoon or night or whatever. But anyway, it's morning for me. I hope you are ready for derivatives of the exponential function. So last time we reviewed exponentials a little bit, just to kind of bring it back into the groove. And today we're going to work on the derivative, okay? So now remember what we talked about when we were talking about exponentials, about how in this class, really what we're focusing on is e to the x. So we want the derivative of e to the x. So we want dx of e to the x. Okay, now, wait for it here. If you want to take the derivative of e to the x, the derivative is e to the x, okay? So I know you're like, wait a minute, you forgot something, you wrote it down or whatever, but here's the dealio. The derivative of e to the x is itself, okay? So e to the x and the derivative of e to the x are the same thing. And the reason why is, remember that what we're doing when we're showing derivative is we're looking at rate of change. But remember what e to the x is a growth rate function. So the fact that e to the x is already showing rate of change, and it's the ideal, okay, the ideal rate of change, it means that it's its own derivative. Now remember, this only works for e to the x. If you were to have like 2 to the x, okay, that's not the case, okay? It doesn't work with any other base other than the e. But again, the nice thing about our class is we only care about this guy, okay? We're not working with this guy over here. So that makes our life that much easier. Okay, now, what that means though is when we go to practice some derivatives here, what we're gonna do is we're gonna throw in some extra stuff. It's not just gonna be e to the x. We might put something up in the exponent, or we might add or multiply something to the e to the x. So the idea behind this is that you're almost always gonna be using the product rule or the chain rule or even the quotient rule, okay? So as our first example, so we're gonna just find some derivatives here. They give us f of x is x squared e to the x. So x squared times e to the x, which I know we haven't practiced it in a while, but this means that we're going back to the product rule to solve this one. So if we want the derivative here, we'll say f prime of x, okay? And we'll take the derivative of the first guy, so 2x, leave the second guy alone, plus leave the first guy, take the derivative of the second guy, which is just still e to the x. Ready? So that is what the derivative looks like there. Okay, so let's look at another one. Let's say we had h of x equals e to the x plus 2 to the 3/2 power. Okay, so in this one, we have the e to the x, we have that, but we have it inside another function. So this would be an example of where the chain rule is coming into play. So if we want the derivative here, and let's make a note, you guys, I'm noticing on tests that we're forgetting to put labels. When you're finding derivatives, you always have to put a label to tell people that this function is different than this function, okay? So we need the little prime on there to tell us that. Okay, so here, if we're looking at the chain rule, we'll bring down the 3/2, so we'll go 3/2, leave the inside alone. The new exponent on that will be a 1/2, right? If we subtract 2 over 2. But then we need to do the derivative of the inside. So the inside was 2, or e to the x plus 2. So the derivative is just e to the x. So we end up with 3/2 e to the x times e to the x plus 2 to the 1/2 power. Okay. So the thing about this is that because the e to the x is going to kind of follow you along because it's its own derivative, you're gonna notice that all of these answers are gonna end up having e to the x in them. But as we get a little bit more familiar with this, you're gonna see the e to the x is actually not that bad, and it's really okay to deal with it there. Okay, how about this guy? Y equals e to the 2x. Now, if we're dealing with like the compound continuous interest formula, like PERT, a lot of times we're gonna see values in the exponent, okay? So we're not gonna see this as much as we're gonna see e to the 2x or e to something with an x in it and other things. So this is what we really wanna focus on. Now, the idea here is that we're going to use the chain rule again, because the outside function is the e function, but then inside is the 2x. And the way this works is whenever you have this, you start by just writing down what you have. That's the derivative of the outside function, e to the 2x. But you multiply by the derivative of the exponent, which is 2. 2e to the 2x. Okay, so write down the e to the 2x part and then multiply by the derivative of the exponent. Okay, so let's look at another. Uh-oh, we got a problem here. Well, we might have to take a pause. Most definitely gonna have to take a pause. Okay, gotta go find myself some Windex or something. So I will be back in a minute. Hold on.